Hi there. For this video, we'll be discussing the sum and product in quadratic equations. So basically, in this video, we'll try to derive a formula on how to quickly get the sum and product of the roots given a quadratic equation. So to do this, let's first have this general example. Let's have ax squared plus bx plus c equals 0. Now by the quadratic formula, we know that its roots can be obtained by this negative b plus minus square root of b squared minus 4ac over 2a. And we know that since we are dealing with quadratic, we have at most 2 roots. So we have here x1 equals, say, negative b, and since we have here a plus minus, that means one of the roots will be the plus and the other will be the minus. So in this case, we have plus square root of b squared minus 4ac over 2a, and the second root will be negative b minus this time square root of b squared minus 4ac over 2a. So we'll use up these 2 roots to obtain the formula for the sum of the roots of a quadratic equation. So let's have that one. Let's have x1 plus x2. If we add the 2 roots, we'll have this plus this. So let's copy that one. So we'll add this two up. So let's remove this one to save some space and resize this first and move this up here. So since we have the same denominator, we can simply combine these two into a single denominator. And from here, observe that since we have a plus square root of b squared minus 4ac and minus b squared minus 4ac out here, these two would cancel out. So we'll just obtain negative b minus b is negative 2b over 2a. Cancelling out the 2 out here, we'll be left with negative b over a. And this is the general formula for the sum of the roots of a quadratic equation. If you're asking what a and b is, recall that these are the coefficients of our quadratic equation out here. So let's take note of that one out here. So the sum is given by negative b over a. How about the product? For the product, we'll have x1 times x2. And that will be this one. Oops. Times this one. So multiplying these two, observe that in the numerator, since this is a sum and this is a difference, we'll have a product of a sum and difference. And we know that the outcome for that is simply square of the first term minus the square of the second term. B squared minus 4AC squared all over in the denominator. 2A times 2A will be 4A squared. And from here, simplifying the numerator, we'll have negative B squared is B squared. Then the square of the square root of B squared minus 4AC will simply cancel out the radical sign out here, and we'll obtain B squared minus 4AC over 4A squared. Let's resize this. And from here, we distribute the negative sign to obtain B squared minus B squared plus 4AC over 4A squared. The B squared out here will cancel out, or we'll subtract them to 0, and we'll obtain 4AC over 4A squared. Then we can simplify this 4's out here, and the A over A squared will result to just a single A in the denominator, so we obtain C over A. And that is the general formula for the product of the roots of a quadratic equation. So we have here C over A. And so that is how we derive the sum and product of the roots of the quadratic equation. So let's try this out in an example to visualize it much better. So if we have x squared plus 10x plus 16 equals 0, and we are tasked to find the sum and the product of this quadratic equation, instead of trying to factor it out or applying some factoring methods like completing the square or quadratic formula, we can simply use these formulas. So this saves up much time. First, we determine the coefficients. So we have 1 here for A, 10 here for B, and 16 here for C. So we know that the sum is simply given by negative B over A, or that is simply negative 10 over 1, or simply negative 10. For the product, that is simply C over A, or that is 16 over 1, or simply 16. And that is, these are immediately the answers for this problem. If you want to verify, note that we can factor out the given into x plus 8 times x plus 2 equals 0, which will yield us with x plus 8 equals 0, or x plus 2 equals 0, or x equals negative 8, or x equals negative 2. Observe that if we add these two, we'll obtain negative 10. If we multiply these two, we'll obtain 60. So by applying the sum and product concept, we were able to save time in solving this problem. So this is really useful if you're in competitions or you're in a time-pressured test or exam. Another use of this concept will be showed in this next illustration or example. But first, observe that if we have ax squared plus bx plus c equals 0, and we can divide or multiply 1 over a both sides. Note that we can do this since we know that a is not equal to 0. Since if a is equal to 0, then this will be 0 and we'll only have a linear equation, which is a contradiction since we're dealing with quadratic equations here. So dividing a both sides, we'll obtain x squared plus b over ax plus c over a equals 0. And from here, note that we can rewrite this middle term into x squared minus negative b over a x plus c over a equals 0. And observe now that this one out here is the sum, and this one out here is the product. So with this in mind, note that we can also use the concept of sum and product to quickly determine if we are tasked to find a quadratic equation. So let's try to use this idea. Let's put this one here as a guide. Say if we are given the sum to be 5 over 2 and the product to be 2 over 3, and suppose that we are tasked to find a quadratic equation given this 2. So what we only know is the sum and the product. We don't know the roots of the quadratic equation. So how do we obtain this? Well, using the concept, this concept out here, we know that the quadratic equation given the sum and product is simply x squared minus negative b over a, or simply the sum, which is 5 over 2 x plus 2 over 3, since this is the product, this is c over a, and this is the negative b over a, from out here equals 0. And we now have a quadratic equation. Since we usually don't like to see fractions, what we can do is we can multiply this both sides. Oops. Let's remove this one out here and it's fine. Let's multiply. What do we need to multiply here to remove these denominators? We need to multiply 2 and 3. Or simply, 2 times 3 is 6. So this will become 6x squared minus 6 times 5 is 30 over 2. That is 15x plus 2 times 6 is 12 divided by 3. That is 4 equals 0. And we have now find a quadratic equation that satisfies the given sum and product. So that is the use of the sum and product. A very good tool in many ways in dealing with quadratic equations. Now it's your turn. We have 2 exercises out here. Exercises. So for the first one, if we are given 3x squared minus 11x plus 5 equals 0, your task is to find the sum out here and the product. So this is straightforward. Just use the formula that we have derived in the first part of this video. After that, our next example is the opposite. We are given the sum to be 11 and the product to be negative 5 over 7. Let's fix this 5 out here. And for this one, your goal is to find a quadratic equation that satisfies the given. And as a challenge, the coefficients must be integers. So integer coefficients. So to have integer coefficients, what you do is, like what we did a while ago, you simply multiply a factor to both sides of the equation to eliminate the denominators present, or the denominators present in the coefficients of those terms in the equation. So that's it for this video. Feel free to comment down below your answers and solutions to these exercises. So that's it, and that's all for this video.